Hello everyone, it's Jennifer here. In this video, I'm going to show you how to conduct in-sample test. This is my example data. I have returns of 10 stocks, right? And I also combine this data with the factor returns, MRP, SMB, HML, and risk-free rate. As you know, the in-sample test has two stages. In the first stage, you are required to estimate FF3 or Fama and French 3-factor model for each stock in the sample. That is, for each of the 10 stocks here that I have, I would need to calculate excess returns, which is the return on the stock, minus for the risk-free rate, and use that as the dependent variable. Then, I will regress the dependent variable on the 3-factor returns, which is the market risk premium, MRP, SMB, and HML. With the help of VBA, I can write a command that performs the regression for one stock. Then I use a for loop to repeat the command for all other stocks. So let's do that. Before moving on to VBA, I would like to explain to you the procedure with the workbook commands. So the first step is to calculate stock excess returns. I will do that by creating a column here, right? After calculating excess returns, I will use the data in the column to perform a linear regressions. I will print the regression result into an array next to it. Okay. So let's try to do that with the first stop. So I will calculate the excess return of first stop by taking the step 1 returns minus for the risk-free rate. So this will be my dependent variable. Now I can use the linnest function to perform a regression analysis. The outcome of a linnest function is an array, so I will first select the array here and go to the formula bar here and type in the linnest function. Okay, the first argument will be dependent variable. I will select this one. I press F4 to freeze the range. My dependent variable would be these 3 variables. Press F4. Now this one with the constant, I want to estimate the intercept, or the constant, so I will select true, and I would like for the function to return additional statistics, so I will also select true for the last function. So for this to work, I will press Ctrl Shift Enter. So you see now this is the output from the linnest function. You can also use data analysis toolbox, so you can go back to my PowerPoint slides and you can easily follow that. So I should briefly explain to you how this function works, right? So in the first row here, you have the coefficient, and these coefficients are presented in the reverse order. So my first value here will be the coefficients of the last explanatory variable. So this will be the coefficients associated with the HML variable. And this one here would be the coefficients of the second last, which is the SMB variable here. And this one will be the coefficients of the MRP, which is this one. The last cell here would be the intercept. Okay, so the first row is the coefficient. The second row will be the standard error for the associated coefficients. This guy here is the R square. that guy is r squared. So these are the information that you will need. Okay. So after I have the result for the first regressions, I will store that into this table here. So I will create a table where I have the coefficients of all 10 regression. So I have these coefficient, right? So I have 10 steps, that basically 10 regressions, right? I will have here, this is the coefficient of the SML, SMB, beta, the alpha. Okay, so after I finish the regression for the first step, I will copy this into this results table. Okay, and then I will create another table for standard error. So basically it will be the same, so I just copy this guy here, right? And with the standard error, I will copy the second row from the result table into this one. Okay, I can also calculate r squared right here. So basically I will copy this guys into here. Sorry, I don't know what happened, but basically yeah, so you copy that, and okay, so that's the r squared, and I keep doing that for all of the 10 steps. So once I got this done, right, I can go back and change this to the second step. So basically now my RF would be would equal to C2 minus O2. Okay, and I would do that again. So the result now here would be in this area would be for the second step. I would then copy this to this one, and copy this to this one, copy this to this one. Okay, so you get the idea of how the things how I'm going to do it. So let's open VBA and write a code for these actions. Before we do that, we will need to save this workbook as an Excel enable, the macro enable workbook. So go to save as, and save this into the Excel macro enable workbook, XLSM. Okay, now I will delete these values here. And we will try to do this with VBA. So I will access the VBA window by using Alt F11. So now I just quickly delete all the code I had before. So you can insert a new module by go to Insert Module. Okay. Alright, so I'm going to minimize this. Oh no. Okay. Yeah, I'm just going to minimize the workbook window so you can see it side by side. Okay, so similar as in the previous video, I will create a subroutine by typing sub. So give it a name. I will call it ensemble, brackets, enter. So now you will see there's and sub will automatically appear. Okay. The first thing you would like to do is to name all the ranges so that you can easily refer to them later on. So I will use dim and set function. I will use dim. The first thing I would like to define is the stop returns variable. So I would use stop return. Right. I just use stop red, because the longer you get, the more tedious it gets later on. So I define that as a range, right? And I assign the stop returns data into it. So I will set stop return equal to range. So let's go back to the Excel workbook to see where it starts. Start from cell B2, so I will ignore the header, guys. It starts from B2, right, and ends with K20. So I do B2 K20. Okay, right. I also need to calculate stop access returns, and to do that I will minus risk-free rate from the stop return. So I will create a variable to carry the risk-free rate. So I will dim RS as range, right? Set RF equal to range. As you can see, RF will start from cell O2 and go to O20, right? For my independent variables, I need to regress them on the 3 factors, right? Three factors as range, and I will set 3 factors equal to range. You see it start from L2 and it's end with the last factor here is M20. Okay, so now you have all the input variable set up. Okay, so now I would like to create the output ranges as well. Okay, so with the output ranges, I will have first output would be the access return. So I will create dim maybe access R, okay, as range. Okay, set access R equal to range P2 to P20. Okay. The second output would be the LINNESS result. So I will go dim rec result as range, so rec for regressions. Okay, and set rec result equal to range R2. So you see it start with R1, right, and it ends with U7. So U7, right. Now I have created a table for coefficients, so I will define that as well. Dim coefficient as range, set coefficient equal to range. It starts with x2, right, and it ends with AA11. Okay, I will do the same for the standard error. So I will have standard error as range and set standard error equal to the range of starting from AC2, and it's go up to AF11. With R square, let's set R square as range, set R square equal to range. So with R square, you see that for each of the regression we have one value for R square. So R square will start from HE2, right, HE2 to HE11. Awesome. Right. So now we have defined all of the variables. Okay. So you can take a note here. I will keep a single quotation mark and let's say define variables. Okay. All right. That's step one. Right. Now we have step two. The first stage regression. Okay. Now with first stage regression, we would first need to calculate the stop access returns, right? So it's similar to the workbook regressions, right? We will need first calculate. We need to take the stop return of the return of stop 1, take away the risk-free rate, and we get the first value for our app. And we do the same for the second cell, the third cell, and so on, so that we can have the complete monthly stop access return for stop 1. Alright, so when you do these commands using workbook command, you can simply calculate 1, and then we double click on the cursor here, then you get the results. But when you do VBA, you will need a for loop to do that, because this is basically one function that is applied for many cells. Okay, so I will use for loop. So I have for x here would be an index for the cell number, right? So for x equal to 1, 2, you see, I will start x1, which is the first cell, and let's go to this value here. So basically here we got 19 cells, so x will go from 1 to 19, right? And I will calculate the access return. So I have access r cells x would equal to the stop rate. Oh, okay. So you see, since everything we do here will be repeated for each stop, so before we using x, we calculate this, we need to create another loop that will identify the stop that we are dealing with at the time. So I will create here k equal to 1 from 1 to 10, because we have 10 stop, right? And within the k for loop, we have the x for loop. Okay, so for the x for loop now, you see for the access r cells x, right, we will calculate the stop access returns. And because we are dealing with the first step, the column here would be the column case, and the return value will be this, the first month, so that cells x when x equal to 1. And then we take away the risk-free rate, so that would be RF, right? Cell x. Okay, so that we have access returns. So you see, if you go here, next x, then it will keep repeat for 19 values, right? It will keep repeat for 19 times until it finishes the 19 monthly returns data for the first stop. Now once you got that done, so I can make a comment here. So calculate access return for a stop, right? I can make here a comment. So for each stop in the sample, do this. Okay. what I'm going to do now is to perform a linear regressions for each of those steps, right? So I will use the next function. Yeah, okay. So those results will be printed in the results array. So I will assign that to rec results array. I will have rec results. Okay, equal to. Now I'm going to call up the linnext function, and as you could remember the object hierarchy that I introduced to you before, when we use the VBA, every time we call up the function, we need to call up the whole path, right? So I will do application dot, right, and we're going to use the worksheet function. Yeah. So what I want is the worksheet function, right? And the function name is linnext. So that will be the function I would like to use. The argument will be the same. So the first argument will be the dependent variables. Okay. So dependent variable here would be the access R, right? The dependent variable would be the 3 factors, right? And the other option, as you could remember, the third argument is whether you want to estimate the intercept, which you do, so that's true. And the last argument is whether you would like to perform additional statistics, so that's also true. So that's the regression results. Okay, so after I have the regression result printed here, I will copy the first row, which is the coefficients, would have the coefficient values into the first row of the table. So let's do that. Coefficient. So I will have rows, and this will be the first row, right? So yeah, so this will be the first row. Rows 1 equal to the rec results row 1, and this one you got to be careful. You need to dot and take a value, because if you don't do that, Excel will simply understand this is a logical test whether the first row of the coefficient table is the same as the first row of the regression results. So you need to dot value, so you add the dot value for it to understand that you're trying to assign the value from the regression results back to the coefficient table. And you can do that for the standard error. So I will have standard error rows. Actually, this is not row 1, guys. There should be row K, because that equivalent to step 1. And here you got rec result rows 2, right? Value with the R square. You can have R square rows K as well, right? And that will be the regression results rows K. Row 3, right? Because the R square is actually in the third row, and in the third row, and the first cell in the third row, so that row 3 and cells 1. So that's the information you need. Now this will finish the first everything you need to do for the first step. So you will end this function and you go to next case. So it would repeat the function for all of other stops, right? So you can try to have a look by pressing F8. So now I press F8. Go back to this window and press F8, so you see if your code is running smoothly. So I will firstly doing that. See, so if there is a problem, then it will tell you, and you will have to go back and fix that. So I'm having a problem with this one. Let's see what the problem is. Okay, so see I misspelled the word cells. Right, now let's fix the problem. So before you run, especially for your case when you have 150 stocks, you really want to really check your code before you do it. So you see now it's working fine up to this stage, right? So here you got the regression result. Okay, float variable not set. Now you have another problem here. Everything is good except for this part. Okay, also you have a problem here where you have NA values for alpha, which is strange. Okay. Okay, so these guys here are not estimated. They don't estimate the intercept, so this might be something that we did wrong. Potentially because we defined the independent variable incorrectly. So let's go to the 3 factors, right? I have the 3 factors, or actually you see the 3 factors here is defined up to n, so that's only just S and B, right? It should be here n, right? So I change this into n, right? And so that's one problem. And with the R square, what is the problem with R square? R squared rows, okay? So R squared is AG12, AG11. I'm not sure, I don't think that's the problem, but so rows K, rect result, rows 3, cells 1. Oh, okay, so you need to have a value there. Alright, so let's do this again. Okay, so let's reset the whole thing, right? And then let's try to do this again. So object variable not set. Alright, so you see what we do here. I misspelled the R squared. Okay, so I'm sure we're human and mistake like that always happen. So that's why the F8 function is invented. And you need to check your code before you do it, before you run the whole thing. So you see now it's working for all of my stuff, which it seems fine. So I will finish my debugging. Now I can press F8 and the whole thing, F5, and the whole thing will run for me, right? So you see this is the first pass regressions, right? And with the second pass, you can easily do that with data analysis and regression toolbox. So you can go back to my PowerPoint slides if you don't know how to do that. But since it's a good opportunity to pick up some skills, I will show you how to do that with VBA anyway. In the second pass, we need to average the stock access returns for each stock, right? And then we regress them on the coefficients in the first pass. So the first thing I need to do is to calculate the average return, the average access return for each stocks. So I will create a range here to store the average access returns, right? So I will have 10 values since I have 10 stocks. Now after I calculate the values into here, I will regress this one on these 3 coefficients. Okay. So in my VBA code, I will type step 3, right? Second pass regression. So I also need to define the range, and so I will go back to the define variable section where I define average return as range and set the average return equal to range v2 to v11 and close the brackets. Okay, so here I'm going to use another for loop so I can calculate the stop access return for each stop in my sample. So say for example I start with n, y equal to, actually I can use k again, right? So k equal to 1 from 1 to 10, or if you don't want it to be too confusing, you can try something else. So you can try y, for example. Alright, so for each stop in the sample, I will calculate the stop access returns, and I do that by using the average function. Okay, so I will assign the value into the average range. So average range, right? Cell, I misspelled that again, cells y, right? That would equal to the average of stop returns minus the average of risk-free returns. So I will use the average function, and be similar to the linness function, we need to call that up from the application, right? Dot worksheet function dot average, right? And what do we want to calculate the average here? So you would like to calculate the average of stop returns, right? So that would be stop red dot column y, right? Because it's the first stop. So this is the average return for the first stops. Now you also want to minus for the average return of the risk-free rate, so that will be application, right? Work sheet function average, and this would be RF, right? Average of RF, am I right? Yes, that's correct. Oh, I need another brackets here. Okay, so that's how you calculate the average returns, right? Here you can go next y. Okay, so now you can estimate the regressions. Okay, so I will store the second pass results, say for example down here. Okay, so I also create a table for that. Go back to this first head, this section. So dim second pass as range, right? And set second pass equal to range x14 to AA21. Okay. Now I will store my result second pass. So we also use the linness function, so that's application worksheet function dot linness. Right, my dependent variable would be the average return, so AV red. Yeah, and my independent variables will be the three factors, right? So just to make it easier, you actually can use a function to refer to the subset within a range, but just to keep it simple, I will go back to this one and I use dim function 3 coefficient as range, right? And I set 3 coefficient equal to range x2 to z11, right? And here I will have, this is the 3 coefficients. Okay, true, true. And to be honest, after you run the first pass, got the result, it's probably easier to use regression toolbox, typing this and run the whole code again. But since we're practicing here, let's see how that works, right? So you see now I have 10 stops, so this run quite quickly, right? First line will be coefficient and the standard error will be in the second line. This will be the R-squared. So that is all done for the in-sample test. I hope you can implement this into your assignment easily. Any question, please feel free to post on Moodle forum. Thank you.